Welcome to Hot Topics again in Chapter 7.
And this is the last hot topic. So once you're done with this, you must be at the very end of the course.
That's right. Okay, looking at solving quadratic inequalities, a little bit different than what you've done. It kind of blends a few things together. The first thing you want to do when you see a quadratic inequality is you want to factor this. And I believe right now Alex is going to basically give you problems that are all going to be factorable. And they're pretty simple to factor. This problem right here, the factors of 3, there's only one set, it's 1 and 3. And do those factors add to give you 4? Yes, they do. So we want to solve this piece. So you put in your 1 and your 3, and since we're adding to get a -4, both those signs must be negative. Now remember, when you solve a quadratic by factoring, whether it's an inequality or not, you kind of want to set each piece equal to 0. And so you get x equals 3 here and x equals 1 there. Now that's kind of the beginning. Okay, these aren't the solutions. We're going to come down here, and we're going to mark a 1. Here's 1. And we're going to put a point. Now, since it's less than, you might recall that that's an open circle.
Right, because when there's an equal sign, we put in a dot or a filled-in circle. When it's just less than or greater than, we use an open circle.
Okay, and then on the second one, the 3, we're going to do the same thing, open circle on the 3. Now, what you're looking for is a range of solutions to this inequality. That range will either be all of these numbers here, and normally it's paired with all of these numbers here, or it's all those numbers in the middle. So that's an infinite amount of solutions you're looking for, not just 2 numbers as we've started with.
Right. In other words, in an inequality, there's a long, long list of numbers that will make the inequality true. So what we've basically done is broken all the numbers there are into 3 categories. Numbers smaller than 1, numbers between 1 and 3, and numbers bigger than 3. And we have to look at each of those 3 regions of numbers and see where the numbers are that make the original inequality true.
Okay, so here's what we're going to do. We're going to test some points. We're going to use 0.
0 is always easy to plug in, always a good choice.
We only kind of have one choice here. Now, we could always go decimals.
Yeah, but we're not going to.
We're going to avoid the decimals. And then we'll come over here and we'll choose a 5. So we're going to substitute each one of these numbers into the original inequality and figure out if it satisfies the equation. So let's start with 0. When you start with x equals 0, you end up with 0 squared minus 4 times 0 plus 3 is less than 0. So basically, those cancel out. Is 3 less than 0?
No.
The answer is no. So this whole region does not work, this whole region of answers. So let's try the 2. So we have 2 squared minus 4 times 2 plus 3. Is that less than 0? Well, 2 squared is 4. Take away 8 plus 3. And we have 7 minus 8, which is -1. -1 is less than 0. So this works right here, this region.
So we're going to color it in just like we do in a normal inequality.
Yep. And then the last one, we'll check the 5. Now, we've learned that typically that will not work. If the left side doesn't work, normally the right side doesn't, but we're just going to prove that.
Yeah, at least for this first problem, we'll go ahead and check all 3 regions.
So you get 25, take away 20, plus 3, is that less than 0? So in other words, 28 minus 20 is 8, and we know that 8 is not less than 0. So our solution, if we wanted to write this out, I believe Alex just has you graph it on a number line, but if you were to write this out, this would be x has to be less than 3 and greater than 1.
And as long as we're doing it, let's write in interval notation too, because they'll see that in later courses.
Absolutely. So that would be a 1, 3. So there's 3 ways to write the same solution.
Right. You should be covered no matter what your teacher wants.
That's it. Okay, let's look at another one. This one, same principles that we were just using before. We're going to start out, we're going to factor that inequality. You only have 2 choices for the 8. 1 and 8, 2 and 4. This time we're subtracting to get our middle term. So, we'll go ahead and use an equal sign there. We're going to use the 2 and the 4. And we want a middle term that's a positive 2. So put the plus on the 4 and the negative on the 2. Now when you set each one of those equal to 0, I realize many of you at this point in the course are doing these in your head. but just for the sake of those of you that are so close and your brain's fried, we'll go ahead and write it all out. So there's a 2 and a -4. So those are our boundaries for this one.
Right, and there's just a greater than sign. So once again, we're just going to use an open circle.
So an open circle over the 2 and then an open circle over the -4. Okay, so now our regions are a little wider than they were last time. I'm going to choose -5 here as a number to substitute in. 0, anytime I get a chance, you want to use the 0 here. And then over here, we'll use +5. Okay, so let's start with -5. When x equals -5, I have the following problem. -5 squared plus 2 times -5 minus 8 is greater than 0. So -5 squared is 25, minus 10 minus 8 is greater than 0. Well, this is going to give us a 7.
Yeah.
7 is greater than 0. That satisfies it. So I know this is an area. That whole area is a part of the solution set. Now, trying 0, this one you might want to start doing in your head, but you end up with a 0 squared plus 2 times 0 minus 8. That's 0 plus 0, take away 8. Is it greater than 0? No.
No.
-8 is not greater than 0, so this is not part of our solution set. And our guess is, Bill and I will tell you that this will work, but let's verify it. When you plug in the 5, you get the following, and then squaring that, 25 plus 10, take away 8. So that's 35 minus 8.
Which is 27, and that's certainly true. 27 is greater than 0. So, to summarize, for majority of these inequalities, once you have the 2 points on the number line, the answer will either be between the 2 points, or it'll be these 2 outer regions, like this example here.
Yep. And again, if you want to write this in inequality notation, this is going to be x is less than -4, or x is greater than 2.
And if you want to write it in interval notation, just so we've done it every possible way,
-infinity to -4, and that's a parenthesis, union with 2 to positive infinity.
Right. Remember, a union corresponds to the or word.
All right.
All right, let's do one more example.
All right, this last one, I know Alex presents some of these, and you can tell that the way it's set up is really not a nice looking problem. So what you want to do is, first of all, get x squared positive. So you want to bring the x squared over here and the 2x over here. Now, Bill, would you say keep them all on the left, or would you take them to the right?
Well, the other option you could do would be to multiply both sides by -1. But if you multiply both sides by -1, you have to make sure to flip the sign. Remember, anytime you have an inequality, if you multiply or divide both sides by a negative number, the sign flips. So if you do the approach that Jerry's doing, this kind of takes care of it for you. You don't have to worry about remembering that rule, which frankly is a rule that a lot of students forget.
Yeah, so taking x squared over, obviously it becomes positive. Now, my left side is 0 now. Okay, so I'm going to have x squared and then minus 2x, and now the 3 doesn't change signs because it didn't move. Now, that might be hard to comprehend, so we will tell you, maybe rewrite this the way you're used to writing it, or actually in this case it won't even matter.
Yeah, in this case it doesn't matter, but you could rewrite that as x squared minus 2x minus 3 is less than 0, but for the purpose of solving the inequality, we'll just leave it like this, I think.
We will. All right, your factors of 3 again are just 1 and 3, so this factors using that 3 and 1. We want a -2. So make the 3 negative, the 1 positive. And if you haven't noticed, you're just going to take the opposite number. So 3 and -1 are going to be our parameters for this problem to look at. So let's mark those on our number line down here. Here's 3. And again, open circle here. And then -1 right here.
All right, and so now let's try to shorten your work a little bit. Since we suspect that the answer is either going to be between -1 and 3 or the 2 signs on the outside, maybe to save ourselves a little bit of work, let's just check the number between -1 and 3. Jerry, what's an easy number between -1 and 3 to check?
You know my love
Yeah,
for zeros.
we always pick 0. So let's check 0. If that number works, then that's the solution set between -1 and 3. If that number doesn't work, you can pretty much bet that the 2 other regions will be the answer, and this will save you a little bit of time.
Okay, so up here, substituting in x equals 0, so we're going to have 0 is greater than 0 squared minus 2 times 0 minus 3. So 0 is greater than 0 minus 0 minus 3. Is 0 greater than -3?
Sure.
Yes, it is. So shade in that area.
And now if you wanted to verify that the other 2 regions don't work, you could check -2, say, and +6, and that would show you, we're not going to do it, but it would show you those regions don't work. But generally, in these problems, either between works or on the outside works. So if you want to save yourself a little work, maybe just test that one number there first and do a little bit less work. The only other thing I wanted to mention is if you wanted to, you could have plugged the 0 back in the original equation. It would still give you the same information rather than plugging it into the revised equation we ended up with. Where are these in the book, Jerry?
These are in the very last chapter, I believe the very last section. So chapter 7, the very end. We hope you enjoyed it.
Right, we hope you've enjoyed these Hot Topics videos. And if you're watching this video, you're almost at the end of Alex. Just keep at it a little bit more. Take care.